Hello, hello everybody. Now, someone said my Twitter was kind of messed up. Let me see. Let's see what Yakov was saying. And they make it kind of difficult on Twitch to edit your stuff. Difficult on Twitch to there you go. Channel. Should probably change to Twitter. Let me see what this one is. Yeah, I'll just get rid of that one too. I'll just ditch that. It's kind of weird trying to set up Twitch. Strange. Super weird. Ah, edit panels. Okay. Man. I need to have a UI remake on this thing. Alright, let's remove that one. And remove this one. Okay, good show. All right, thanks for telling me that is messed up. I just have to get back to... All right, the stream manager. All set now. Now I want to stand up. Okay. So I got kind of a prototype going here. Let me check on the finite state machine. I feel like I want to gut this. Maybe turn this into a blog or a README. So let me do that real quick. Because I want to show how small you can make. All right. I did that. Okay, that gets me... Now that's copied out of a thing, so I gotta clean that up some. Right, let's strip this down. Yeah, let's like strip it down as much as we can. Let's see what this looks like without the comments. And then maybe I'll bring the comments back. Ah, that's what I thought. Nice. So about 53 lines of code. Okay, let me undo that. Or leave it. Let me think. Yeah, you know, I think I'll use the README to document it. Yeah, let me do that again. Because I'm more or less pulling it from another project, so I think I gotta go in and clean this up some. Okay, cool. All right, perfect. Then let's check out the FSM test. Yeah, that's pretty good. All right. We've got some design by contract there, so let's do that one next. All right, so this is mostly taken from the C++ version because I want them to kind of be about the same. And the only thing I'm not including is you would almost always have something called an invariant function. But those are usually put like on a class or a state machine. They get run all the time. Like when you're doing testing, you just keep running the invariant. All right, so let's get this to work. All right, just want to do that. Yeah, you know what? I'll just do it with the regex. There we go. That doubles it up. All right, a little bit of cleanup. Yeah, I could probably just do it again. All right. Got some functions, and then let's export them all. Have post twice and pre twice. Nuke those. Should be all I need. And then these. Alright, that won't do anything, but it'll get us a little test going, make sure we got our imports working. Alright. Oh. I gotta figure out how to tell PowerShell to not do that. I never want to know. Okay, cool. Got a basic import. Alright, log is pretty simple. We'll just keep it real simple. Nothing complex. Oh no, actually we're going to do our own exceptions. Throw. We now also have to log. Alright, make sure that works. Alright, we got that. Let's cause an exception. Whoa. My hand is in the wrong place. So I probably need to have check error have the message. Oh yeah, forgot about that. Okay. We can work on that next. bet there's a better error I can inherit from, so we'll just change that up at some point. Alright, really simple, do that. These are pretty much like check. You know, you don't even need the log. Yeah. How far can I strip this? Yeah, you don't need log. Using that somewhere. There we go. All right, we get the sentinel error. Okay. And then we'll turn the, yeah, we'll turn that error exception to something a little more official. And we do need one more version of pre and post. Interesting. Yeah, we need a version that takes a function instead. Let's call it test func. No, actually, test CB. Yeah, let's do it that way. Yeah, kind of inverty, but that's fine. Let me see. Actually, let's do it without, make sure it throws. Yeah. All right. Getting them to work. And then we normally want to be able to get back, like a backtrace off that. Although it's not too useful. If I remember in JavaScript, it's kind of a pain in the ass. Let's confirm that works. Okay, post condition error, not a problem. Okay, that gives us a basic, simple little design by contract thing. Now, these are all really similar. I believe... Can I do this? I can't. Downside is always going to show... Oh, okay. The hell is this song? Like a slow dance at a bad junior high school. Let's see if I like that. It does make the code smaller. Let's see how we can get the backtrace out of it. Is it just console.trace? Can you add a message to it? Okay, works for me. Perfect. Let's do it. I forgot how to do... Man, when you code too many languages, man, it's constantly Alzheimer's. I have coding Alzheimer's. Nice, so that's all expressed in terms of check. Check does the trace, then throws the error again. Alright, let's try it. Nice. Alright, so now we need to use a standard error on it. We just inherit from like error? think so. And then... Okay, almost. Oh, I am not remembering the... That is so funny. I'm gonna see it, then suddenly remember everything. Oh, $sign. Classic. All right, there we go. Nice. So then should it do a trace? Yeah, I think it is, because the trace is going to happen at where the error exists, and then the catch will be a separate location. Which comes up very often in JavaScript because you have these async functions kind of get detached, and so when you catch exceptions, they sometimes will be like have a weird stack trace or not in the right spot. Right. Okay. So let's see what we got. I think that's designed by contract for JavaScript working mostly. Let's do an example. La, 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 la. Oh. Okay. So I can do precondition. Yeah, it's like a simple little demo. And then result equals x plus y. This is like a pointless little example. The post condition is guarantees that x is going to be greater than 100. I wonder if I even need to have, if I could print out the code of the function. That'd be better than that. Yeah, let's just do something real stupid, like, yeah, real stupid. Yeah, see what that does. Oh, keep getting that wrong. Aha. Okay, test callback is not working. Oh, I got that backwards. You know what? Let's flip those. If I'm making that mistake. Well, let me see what that looks like. Oh, what looks better? Yeah, let's just keep it consistent. That way it's consistent with everything. Okay. X must be less than Y. It should be. Let's just throw in. Alright, so I must have an error in the check function. Okay. Actually, it's probably because I have that. Duh. Now, it's sort of pointless to do that, but the idea is with pre and post conditions, you want to be able to do like a few things. So that's why it's a function callback. Because otherwise you would just come in and you would just do a check. If all you want is a simple boolean, you do that. But this is more of like a documentation for, these are all the things that this function guarantees. So when the function exits, you do a post and it says, hey, this isn't right. Now, this is all nonsense. There's no point in doing this, just to kind of demonstrate it works. Okay, cool. Wow. Man, I get caught with my own. One of the reasons why I write my functions this way is it catches that error. Right? If you use the arrow functions by default, then you have to use let or const. But I get stuck doing my own stuff. Sentinel error. Oh, I probably have the logging in that wrong. Yeah. Oh, this should be less than 100. Less than or equal to 100, right? If I do modulus, hold up. Yeah, mod 99 mod 100, and then 1. Yeah, it would be 0 to 100. Yeah, okay. So less than 100. Yep, should be good. Test DBC is not a function. Yeah, so these now have to be rewritten. Yeah, I'm going to go with this form instead. I don't know. Which one do I like better? Ideally, you'd want to print the contents of the code, but I'm trying to keep this real simple. Like someone could implement this in less than an hour. It's kind of the point of the blog post is things like finite state machines and design by contract can be used in any language, anywhere, and they give you tons of advantages, and they're crazy easy to implement. So you give yourself about an hour, and in every language you can have these things. Okay, that's what we expect to see. All right, let's review this real quick. Get rid of that. That's probably not actually testing what I think it is. Is it the Knight Rider theme? Okay. All right, cool. That works. All right, simple little test demonstrates it. How much code is that? Yeah, 30 lines of code. Not bad. Okay, that works. Okay, that gets that. For folks who are curious, I'm gonna grab that Git repo link. I'm just gonna start pulling out like useful chunks of code people can drop into their projects. Should be MIT licensed, I think. Yeah. Hey Johnny, how you doing, man? I just signed I had to pay for QuickBooks again. $700, dude. I gotta get off it, but they won't give you your data. Like, as far as I know, that's illegal. Yeah, I use it for like 3 weeks a year, and I only use it because my accountant insists on using it. I hate it. It's terrible. I'm pretty damn sure that they can't keep your data locked up and force you to pay for it. So I had 2 days to get my data off. I didn't realize that I had one of the credit card numbers stolen and I had to cancel it. I didn't realize Intuit was charging it. And then they email you, they go, it's canceled. And there's one time. They don't say anything about it. It's just a huge scam. So anyways, I'd like to get on something like FreshBooks or Waze Accounting, but it all depends on if, well, maybe I just find a better accountant. I don't know. Anyways, right after I signed up for QuickBooks, and I mentioned this on Twitter, I start getting phone calls from Russia. Like, I've gotten like 10 of them. It kind of worries me. And then a couple nights ago, I had a fake charge to a website. I'm like, oh, Jesus, I got this card number. I got to go cancel it. I haven't called my bank yet, and I'm just like, okay, I got to call them later today. But yeah, so now my phone goes off. I'm like, wait, I'm just waiting for someone to like accidentally. The card they stole though has like no money on it, so it's like it's one that I have just like there's nothing on it. All right, cool. Alright, so that's JavaScript. Let's do Python. Let's change this music, because it is making me want to cry. Yeah. I don't know, is this working for everybody else? Good enough for me. Alright, Python. Python. Same sort of deal for Python. Okay, so I have a finite state machine I stole from another project. I think this is in my book, Learn More Python the Hard Way. Yeah, it's dead simple. Doing these in Python is very easy. Like, this is all you need. You don't even need, like, any special gear. You just have a module with functions in it. And then state transitions are just, yeah, you just look at the event, and you return the next state. And you can do an epsilon transition with this. Just call the function and return it. It's easy. It's definitely the easiest one. Yeah, I need to be pumped, but not. I'm pretty sure if I was playing metal, nobody would come watch. So this is as energetic of music I can probably play. I should just do like a one night. It's like 9 p.m. on a Friday. Death metal and programming with Zed. Okay, I think that's all I need for state machines. I could care less. For Python, this is it. You don't need much more. Remember, the point of the blog post is like you can get a hell of a lot with very little code. I mean, technically, this is all you need for Python, which is pretty nice. I mean, in theory, you could do the same thing in JavaScript, but I think the JavaScript one I made a little more complex if you're going to study it. It's still only like 15 lines of code, and then the C++ one is, what, 23 lines of code? Yeah, that's the whole thing. 28 lines of code. Yeah, it's just based on this idea that, like, you know what? You don't need a lot of code, and you get a hell of a lot of stuff out of it. Like, so much good stuff with just, like, a little bit of that finite state machine, a bit of design by contract, and you've got, like, some solid code in any language. Okay, next, Python. You know, I'm going to kill all these. Clean the palette. Let me think. Python. Okay, check, pre-post, sentinel. Man, I don't even know how to do def. Okay. Man, switching languages is brutal. This is the average web developer experience. No, this is wrong. Yeah. Test callback. And that can also be a lambda, but Python's lambdas are kind of weird. I suppose it'll work. All right, we need to test. I'm also avoiding any test frameworks or any kind of like official test thing. You know, the idea is like very minimal effort to get a lot. So if you had to set up like a whole test environment and stuff, it just wouldn't work. Is lambda even worth it? I'll look at lambda's limitations in Python. I always forget what those are. Yep, that's not it. Cite python.org, because the entire internet is full of garbage. Yeah, I think lambda is just not even worth it. Lambda expression parameter list, followed by expression. Yeah, it doesn't work like JavaScript or C++. They have very good anonymous functions. Yeah, lots of people complain about it. Yeah. There's proposals for it. Alright, we'll do. Yeah, I think with Python you're kind of limited to... because you can't do multiple lines, so they end up being not much better than just like 1 equals 2, right? Yeah, the point of using the function is like pre-checks and post-checks, you tend to have to check like 4 or 5 things. Right. So I can mention that in the blog post. It's mostly documentation because there's really not much of a difference between a check and pre and post in that case. Let's confirm the basics work. Why the hell did I say that? Oh, it's up there. Damn it. Good, that works. And I keep doing that. It's from the C++ setup. Because with C++, you have to be in the build directory to get accurate line numbers. Because you can't tell the C++ compiler, actually the source code's over here. Or at least Ninja or whatever build tool doesn't do it. There we go. Okay. So let me think. Like, I could strip this to the very bone with... Let's see how that works. One of the points, though, is that you have an ability to catch different exceptions. So I'm thinking in blog post, maybe I could do the Python example first and say this is like as tiny as you can make this. And then use that, expand with JavaScript, you can do a bit more. In C++, you can even make a simple system with C++. To kind of show like, even a language like C++, which is known for insane boilerplate, you can get a very tiny, very functional system. Yeah, because these don't really do much more than that. Alright, let's run that real quick. Yeah, it's going to fail on the first one. Alright, so let's make real exceptions just like the other one, and I totally forget how to do that. Because I don't code Python as much. Man, I need to go back to my own damn book. I actually do that, so like if I have to work on more of the book or the next book or something like that, I'll go back through all my own courses real quick. Yes, okay. Inherits from exception, okay, cool. Alright, same kind of concept. Probably do that. Yeah, let's do that. Okay. Check pre-post. So now, if not test, raise. Yeah, let's just do check error. That should be it. And actually, we can just do this. Yeah, because the Python one, it can't be as flexible as the other ones. Alright, and then we want this to be... Make that? It did not. Okay, let's see what that exception should be. Oh, Jesus. Can we add the message? Is that a standard? Okay, good. Yeah, let's do that. Yeah, I think that gets you like pretty much everything that you need. Okay. What's the syntax for Python catching? As, okay. Oh, did I call this? Yeah, because I was going to make these a callback. Oh, just raise. Oh, and that doesn't even have a message. Okay, so Sentinel is next. Okay, I think we got it. Now, printing it out, let me see. For the demo, I probably should just do that. Yeah. So let's do that. Okay, cool. That works. Let's confirm it as E. All right. And then logging stack trays. Maybe throw something in that's like for... Python by default doesn't print out the backtrace. Python. Oh, it's the old one. I use the trace-spec library then. Yeah, let's demo that too. Let's do this one. Oh, I must have read that wrong. What the hell? Why is it? Okay, so maybe I should throw that in. There's a way to just dump the track. Let's just try print stack. Oh, what is going on with my keyboard? See what that does. Yeah, maybe I want to throw that into the library and then you can get it ahead of time. Or is that going to be too fancy? See what that does. Let's clear that. Yeah, it works. Can we skip that though? Yeah, I think if you set F to this, it'll skip it. No. Alright, what's the point of that? Unless we want to peel one off. Negative limits? Odd. Okay, hold up. So if you do that, is that going to do what I want? Oh yeah, okay. Weird. Alright, that works. Yes, if you pass a negative to it, so I don't want all the stack traces to go into the check function. I want them to like be outside the check function. So this is going to do it to there. So then we can do print. And yeah, maybe do a bit of formatting like that. Yeah, I'll use that as an example. Like, you can make it way more useful. So then you get the stack frame. Tells you where that check was triggered, which is line 5. We go look at line 5. And it's this line right here. Very useful. so I wonder if I can then do the exact same thing with this. I can do, yeah, let's see if that works, and then I can also do that stack frame thing. Yeah, maybe. Actually, just do this. Nice. That works. Wait, why does that work? That should not work. That's kind of weird. Okay, that works. Alright, so let me just do this. Now, why does that stack frame work? Well, odd. Again, Sentinel we'll leave like that. Okay, cool. So it prints the stack trace and then raises. I could probably do... Yeah, that's fine. Yeah, so now it's doing that. Let me add a little bit of formatting, make it a little nicer. Cool. You get little exceptions all over. Yeah, and then the Sentinel, same deal. Cool. Yeah, that's perfect. Okay, got it. I'll have to work on that README a bit. Oh, Jesus. Don't ever git add asterisks. Alright, cool. Alright, I think that's all I need for the blog post. Yeah, I think I might do it as a series too, like just simple things that give you quite a lot of value. Alright, and actually I am very tired. Not sure why. I had perfectly good sleep last night. So, that is all done, folks. If anyone got questions, ask me and I'll help you out. I'll be hanging around for like, maybe like 10 more minutes. If you got questions, go for it. If you want that code, let me drop that link one more time. It's nothing fancy. It's just designed to kind of give you some ideas. Like, you can do quite a lot with very little. Now you notice I didn't really go like crazy formal or like super awesome programmer. So it's something that just about anybody could, you can probably go through that and understand that. But I will have to add more explanation. That's where the blog post will come in. But check it out. If you don't know what design by contract is, it's just a very simple way of sort of documenting what is allowed going into a function, what is going to happen when the function leaves, and then the sentinel thing is you toss this into anything where the code should not run. So put it in, like, if you have a switch case statement, put it in the default. If you have like an if, make an else and throw it in the else. And what'll happen is if anything happens to trigger that else, you get an explosion, and then you messed up your logic. There's one more concept that goes into design by contract, but it doesn't fit in this. But what you would do, right, is let me just make I'll do it here. So you might have like let's say you got a class like person, something dumb like that. Well, you would make a invariant. And the invariant's job is you would call it, like you would have some sort of debug mode that would call this all the time. And you would just confirm things like assert, well, we'll use our thing up there, check name doesn't equal none. Right? You can say age is less than 100. Let's say you don't expect to have anyone less than 100. And what you're doing when you do this is, as your system operates, let's say you're running your test suites, you're doing your tests and whatnot, you just constantly call invariant. And this is sort of like catching any assumptions you have. So you make a class and you just say, I assume that age will always be less than 100 and name will never be none. And then suddenly all these errors will pop up. If anyone changes any code, then if you documented the assumptions, they missed it, it'll pop up. And sort of the same thing with the post condition and the precondition stuff. They're just basically documenting your assumptions about how stuff's supposed to work. But that doesn't really go in like a library. This is more something you just add to your systems, your classes, or whatever you're using. And then you just have to have something that runs it. Usually a test suite, you'll just like do a whole bunch of stuff in your test suite and then just go invariant, invariant, invariant. And it confirms that all of the assumptions are still valid. So that's something that I'll more mention in the blog post. And then, so the idea with like a little DBC library like this, it's just like nothing more than 20 something lines of code. Now, this could be way better. You could use, what are those things? Function decorators. And that would be way better in Python. But that's like a whole thing. You just have these, you start sprinkling them in your code and sort of documenting what's allowed, what's not allowed, what should happen, what shouldn't happen. Eventually you'll start to see that the code kind of is defensive and catches its own errors. If that makes sense. And then finite state machines is the other one. You know, like in Python, you can make very simple finite state machines, just like this. And And you don't need to get fancy, nothing like what you probably learned in your math class. It's nothing more than functions that return themselves based on events. That's it. And what these will do is, I use finite state machines anytime I have to deal with random or asynchronous events from one source, but usually multiple sources. So let's say you've got a GUI. People can click on buttons at any time. And then you've got a network source, and it can have results come in at any time. So a state machine will actually organize all those things. So you could have, like, someone could have a GUI, and then a user is clicking on them. It's my terrible user drawn with my mouse. So the user is clicking on the GUI, and then you also have events coming in from the network, and the GUI has to maintain itself, right? It has to handle random things coming from here and random things coming from here. So a state machine is very good at that, because as the events come in, you're in different states. You can update the GUI as you get the event, present it to the user, lock things they can't click on, things like that. And it doesn't take much, and it vastly improves the stability of things like GUIs and handling network protocols, dealing with, like, in my case, I have a program that launches a process and also has to display info to the user, and the process can be random in what it returns. So there you go. Like, state machines are incredibly simple to implement. Very simple ones. Like, you can get really nuts with them. You can go very crazy with them, but just a simple one is really easy. Here's a C++ one. Like, it doesn't do much. Again, like, it's like about 30 lines of code. It seems like that's what you need for, like, a lot of win, like big win. And just ignore this horrendous batch of wizard C macro probably stuff that makes C programmers cry. What is like, let's do that. Yeah. Okay. Nobody sees that. But yeah, just a very simple state machine that knows about its states. Very easy to use. And then JavaScript is sort of the same deal. You don't need much to make a little design by contract system. Doesn't really need more than about 30 lines of code. Same thing with a JavaScript FSM. I kind of make this one a bit more complex. You could do it like the Python one, right? Where it just returns functions. Functions just return themselves. But I made this one do a bit more. So you can actually pass, and you make a FSM class, and it knows how to operate itself. So you just make a little test operator machine, and then you just name the functions for the states, and when they get different events, there you go. Oh no, this one is inverted. Oh, I gotta remember to do that. Yeah, I gotta remind myself to mention that. So there's two ways to think about a state machine. You have a bunch of states that receive events, or you have a bunch of events. Oh man, I'm gonna get this totally wrong. So basically, you can focus on the events, and that's what you encode, and then states determine what happens based on the event, or you do the opposite, where you receive an event, but you're in a state, so you transition. So I think I got to go back through this one, because I find the one where you're in a state and you receive an event to be a lot easier to understand. Yeah, this one is inverted. So this is, you receive open event, and then if you're in this state, you go to that. The other ones are the other way around, where you are in a state and then you receive events and transition that way. All right, so I gotta remember to mention that. But anyways, either way, it's incredibly easy to use, and they're very useful, like very useful. Just those two things probably make, I always go in, every time I make a software project, I'm throwing those two things in real quick. Just because they make things so much more stable. And then finally, I think the only reason, or the other thing that's really great about them is they work in any language. So if you've got a language like Erlang or Elixir, you kind of already have a lot of state machine stuff already built in. If you're using a language that, like Ada, or what other languages have like design by contract stuff, like really solid, those languages you're fine. But or even a language that's got a solid type system, you might not use as much design by contract, right? But in some languages where you don't have that and you need to get some stability, this is like going to get you pretty far for very little. Okay, cool. All right, everybody. Thank you for stopping by. Drop me questions if you got it while I close up shop. And I was thinking I would stream again tonight, but probably not. I think I'm going to crash pretty soon. All right, talk to you soon.